I'm Professor Brad Fulton, and welcome to my Stats podcast. This is an edited audio recording of my course. Each lecture is its own episode, and there's a total of 24 lectures. This course provides an introduction to the quantitative methods social scientists and data analysts use to collect and evaluate empirical data about society. Through this course, you will learn to gather, describe, and analyze data with an emphasis on the application and interpretation of these methods. This course will also help you to be a more informed and critical reader of academic research, public opinion polling, and advertisement claims that present statistical evidence. Although some of the current events I reference might be dated, the content is timeless. I hope you enjoy this lecture, and if you have any questions, you can email me at bradrfulton@gmail.com.
So why statistics? How many of you have seen Moneyball? 1, 2, 3. Okay. 2/3. This is happening across all fields. Fields are getting inundated with data. I mean, everything from marketing to medicine to sports. There's just all this data out there, and it's kind of like, well, what good is all this data? What can we do with it? And I thought Moneyball was a good example of how data, and in particular, a statistical analysis of data, can be used to make the team better, to help the team actually win. And so I thought we could start with a clip.
Moneyball, the new film from Sony Pictures, details the Oakland A's success using a new approach to statistics. But how did that way of thinking get started? The seed was planted, oddly enough, by an aspiring writer in Kansas working nights at a pork and beans cannery. In 1977, James compiled all these numbers into 68 pages and started making photocopies. He took out a tiny ad in the Sporting News, and the baseball abstract was born. Bill James' way of analyzing baseball was finally beginning to take hold in the major leagues, led by a progressive front office in the East Bay that would soon take the American League by storm.
So to inspire you, but actually I think it's fascinating. Did you hear him say regression on there? That's what we'll be learning. The general idea is to help you see how the stuff that we're actually learning in this class can be applied to everyday life. It isn't just something that you necessarily have to be obligated or forced to do, but hopefully it has applications beyond. So why statistics? Statistics is basically all about data, and that's going to be an overarching focus of this course is sort of what is the information that we're analyzing. And so we're going to be looking at collecting data, describing data, what are the characteristics of the data, then analyzing the data, and then after analyzing, sort of this is where you put on your sociological hat and you interpret the results. So you have these outcomes or these relationships and you say, okay, well, what's going on here? Why is this relationship here? Or why is this outcome being caused by these factors? Or is it? And then ultimately making decisions. If you're in a public policy arena or if you're on any type of decision-making team where you're looking at these results and you're saying, well, we need to make decisions, and so how can we use these outcomes or these results to make good decisions? So data is everywhere. It gives you information, and basically the thing is that you're going to be given statistical claims or statistical evidence, and you need to evaluate, is this a valid claim? Is this good evidence? And should I make a decision based off of it? So I have a 1-month-old girl, and when a baby's born, they do all these screens. They do all these tests. They do blood work, and they just sort of check for everything. And there's like 30 different tests that they do. And our daughter failed one of the tests. And these are like serious tests. And so this one was related to the thyroid, which is related to sort of neurological development and physiological development. And so the doctor calls us in and they say, we need to do a retest because her levels were low. They were 5 when they should have been a 10. And so they did a retest, and it turned out it was now a 4 where it should have been a 10. And so they said, fortunately, this is treatable, but if we don't treat it, it would sort of hinder her growth and development. And so as a statistician, I was like, well, okay, first of all, how common is this? Is my daughter 1 in a million where like you've never seen this before, or is she 1 in 100 who has this condition? Because that's important, and that's, again, statistics. How many people actually have this condition? The doctor said, well, it's about 1 in 4,000. And so we know that not every kid gets it, but enough people get it so that they know how to treat it. You don't want to be 1 in a million with medical issues. You want to be 1 in 100 or something where it's common. The next thing I asked was, well, in general, when you test day to day, how much does that number vary? You know, if you look at your sugar levels If you test how much sugar is in your blood right after a meal, it's going to be really high. But then if you test it right after you wake up in the morning, it's going to be really low. And so I go, how much variability is there in that number? And he said that number is pretty stable because your body needs this continual flow. And so no matter when we test it, no matter what time of day, what we get is what it is. So then they put her on medication to sort of boost up her thyroid hormone that she's getting. And so I was like, well, how much should we put into her system? Should we put it so that she has 15 to sort of compensate or whatever? I'm a parent. I have a child. She has a medical condition. And I could go in there sort of blindly and let the doctor just say, she should have a 10, but she got a 5, so we need to treat her. And be like, okay. Or I could sort of ask informed questions, sort of understand the statistics behind it so that I have a better sense of what we're dealing with. And so by understanding these concepts that we're going to be looking at, that will help you to make better decisions about things you do in life. So we're looking, this section today is going to be on collecting data, the structure of data. The topics will be cases, variables, and values, categorical and quantitative variables, and then explanatory and response variables. So this is like compressed lecture, but this is what we're going to be going over. One of the hardest things about this class, and to me the most confusing thing, is it's foreign terms. It's terms, in fact, they're not necessarily foreign, like you've heard them before, but when they use them in statistics, they mean something very different. And so one of the things that will really, really help you in this class is sort of coming up with your own glossary so that when terms start flying around, you'll know what we're talking about, because some of them are just so subtly different from one another that you think you're talking about one thing, but really it's something different. And so as you're reading, when you come across the term, write it down and sort of write your own definition of it. And actually that will probably help you on your cheat sheet. Just have all those terms so that then when you get a question on the exam and I ask about sample statistic, you can be like, oh, sample statistic. Okay, here's what that is, and here's what I need to answer. And I'll try and help you with here, like having terms, but all these that I show here are also in the book. So again, don't fret about writing them down because they're also going to be on Sakai, so you can see them there. So data, it's a set of measurements taken on a set of individual units. So if you use the example with my daughter, they took 30 different measurements, and so they gathered data on my daughter. So the data set would be all the kids in North Carolina who were born on May 27th, who got these 30 tests, and so you'd have a collection of all these people with information on them, and they'd be combined into a data set, and you could blow that out to all the kids born in 2012, all the kids born throughout the U.S., and you could then see what proportion of kids fail test number 23. And that's the way that you can take the data and the larger data set to sort of get, well, how common of a concern is this? A data set is typically found in a table, so similar to Excel spreadsheets. You have rows and columns and cells. So almost any data set that you're going to look at is going to have this feature. It's going to look just like an Excel spreadsheet, and there's defining characteristics of the table. So the first would be a case. The case is the unit described by a set of data. Already the terms are kind of getting confusing because case means some things in different areas and units mean other things. But basically a unit is the object that we're gathering data on. It could be an individual, it could be a group like a team, it could be an object like something in nature, or it could be an incident like a cancer outbreak. So it's basically what is the object of interest. In the case of my daughter, the object of interest is newborns. So the unit would be newborns. Can someone think of other objects of interest that you would study?
Maybe new graduates.
Yeah. So recent grads, that'd be a good one. And then what would be another example of a unit that's not a person? Diseases, yeah. So you could look at any type of disease and see that as an incident and track all those incidents. Any other, Food, yeah. So the unit could be food types. And so then in the data you could collect on it is fat content, sugar content, protein. So yeah, really it's anything sort of a collection that you're going to want to compare with each other. Another thing could be like organizations. There's a lot of different things. So it's just, but more so the thing that you need to know when you look at something, you need to ask yourself, what is the unit that they're analyzing? What's the thing that they're gathering measurements on? Because if you don't get that, then you're going to be really confused, because you're going to say, well, did they sample a bunch of people or did they sample a bunch of food? So that's just an important thing. So in your data set or your Excel sheet, when you look at data, each row of the data set corresponds to a different case. Think of the Excel spreadsheet and you have row 1, 2, 3, 4, 5, 6. Again, with the case of my daughter, row 1 would be Emily Fulton. Row 2 would be the next person. Row 3 would be the next person. Row 4, the next person. That's sort of how it's ordered in the data set. The other sort of characteristic of the data set would be the variable. And the variable is the characteristic of a case that varies. Remember, I said my daughter had 30 different tests on her. And so there's 30 different variables that we're looking at, and it varies by each person. So test number 1, my daughter gets a certain value, and all the other people who are tested have a different value. So the values are going to vary across people, and each column corresponds to a different variable. So in the data set with my daughter, how many columns would there be? 30, exactly. So it could be, if we use Chris's example of food types, Chris, give some things that would be on the rows.
I guess fat would mean like fat foods, kind of like burgers, and then you do like steaks, chicken, and apples, bananas.
So would that be rows or columns?
I guess that'd be more column.
That's good. So what are the cases, or what's the unit that we're going to be taking measurements on?
I guess what you're looking for in a certain kind of foods, I guess. If it's looking for a certain, I think if you're just looking for like sugars.
Well, when you originally brought it up, you said, let's look at food.
Mm-hmm.
And so we need to have a collection of food types.
Okay.
And so give me 3 food items or types.
I would say like bread, bread, milk, meat.
Bread, milk, and meat. So that would be each row.
Okay.
Bread, milk, meat. And then what are the things that you're interested in knowing about the bread, milk, and meat?
I guess you could say the sugar.
Okay, so sugar would be one column. Fat, and then protein. This is conceptually important because you kind of, when you look at a data set, you kind of need to know, what is it that I'm studying? What are the units? And then what do I want to know about each of those units? And then the last part of the Excel spreadsheet that we're looking at is the values. We have our rows, we have our columns, and then each cell contains the value. So let's say we're using the food example. We have bread, and we want to know sugar content. Basically, each cell, like if you sort of look at row of bread with column of sugar, that would bring you to the cell. Let's say the number is 6 in there. That would say, okay, bread has a sugar count of 6.
So where's the difference between data and data set then?
Okay,
Would data
yeah.
be like a column within it, or like?
So, no, that's good. So again, I'll use my daughter as the example. They tested her. When she was in the hospital, they tested her. So they wrote down her name, Emily, and they had these 30 tests, and they wrote them all down, and it was just on a piece of paper.
Okay.
And then at the end of the day, someone in the computer department was handed a stack of 50 pieces of paper with all different newborns. So Emily and then 49 others. Emily's is the data on Emily. The data set would be combining all of those. So data set is the main thing, because you're not going to do statistical analysis on one person.
Okay.
You need sort of a set of data on multiple people or multiple units. Throughout this course, we're going to be looking at data sets. So sort of understanding this and sort of navigating these terms. And after a while, it'll sort of become clear sort of what we're looking at, but this is a good overview of how it's broken down. So that each cell contains the value for a particular characteristic. So now variables. This is like a key component of data. To help you remember, variables vary. A thing that wouldn't be a variable in the situation with my daughter would be a column called human being, because that doesn't vary by unit. They're all going to be yes. You think so. So variables are things that vary across people. That's what we're interested in, is what causes my daughter's level to be low, whereas other people's are high. There's a variation there. It wouldn't be interesting to ask the question, why is my daughter a human being? We're not comparing her to any non-human beings. So variables are the things that actually are going to vary across the people or organizations that you're looking at. with my daughter, I've been using blood samples, whatever, which is kind of vague and not known. But in sociology, we have very interesting and sort of commonly known characteristics that vary across people and organizations. And so some of them would be like race and ethnicity, religious belief, income, age, education level. And so this is, I think, where sociologists have a corner on the market. The stuff that we study is socially relevant and interesting to people. And it's easily grasped. Like everyone kind of knows what education is, what income is. So then the things that we study, people are like, oh, what affects income? Or what affects a person's religious beliefs? So then the varies part, it varies between cases. You could look at the religion of people in this room, there's going to be variation. Or at least if we have a large enough group, there's going to be variation between people. But it can also vary within a case over time. If we use the religion example, what my religion was as a child might be different from what my religion is as an adult. So variation can also occur within a case, or some can't. Race and ethnicity can't. Income definitely can't. Age definitely will. Education level will. Some things can vary within case and some can't. And it's sort of intuitive. You just sort of ask yourself, is this something that is mutable, or can it change over time, or is it something that's part of your essential core? And then the last one would be variation between cases over time. And it's basically just the combination of these two. Like my religion might switch from A to B, and Chris's religion might switch from C to B. And so then there's a lot of variation going on. But the main thing is that we're interested in characteristics that vary. We're not interested in things that aren't going to vary between people. So it doesn't have to vary within yourself. So let's say gender, you'd be like, oh, gender doesn't vary, so we're not interested in it. Well, gender does vary between cases. So you would be interested in it. So if there's any type of variation, that's a variable that we're interested in. Okay, so that's sort of like the nuts and bolts of data sets. So this is an actual data set. The first question I'd have is, what are the cases? Yeah. Countries. Very good. Okay. And then what are the variables?
The columns.
Yes, exactly. So then we have a value 3.7 right here. Rachel, what is that? Just interpret that. What does that tell me?
About the health in Afghanistan.
Yeah, so it's the health score for Afghanistan. And then what does this one right here? It's empty. What does that tell? What should be there, or what isn't there, or what's the problem with that? So does it mean there's no HIV in Afghanistan?
No, it's just because we don't know.
Okay, so it's just not available. So does this help sort of make it more concrete when we're talking about cases and then variables, and then you can see the values vary by country? And so this one is sort of like a snapshot. It's just one point in time. The variation is going to be between cases versus, we could say, okay, 10 years from now, let's look at the population and all these things for these different countries. And that would be then variation over time within a particular case. Any questions about data sets that we'd be looking at? Okay, here's one. Duke students. This is like an ongoing study of Duke students and sort of seeing characteristics of Duke students. It would be students. So each row would represent a student. And basically, again, we sort of gather data. This is a study that's being done at Duke with incoming students that tracks them all the way through. It doesn't survey every student. It takes a sample of students, and it just basically gathers information on them as they come in and then throughout their time at Duke and then even after they graduate. And so what this sort of contains is rich information about what type of students are Duke students and what patterns can we see, given sort of how do male students differ from female students, and how do students who are stronger in math and in verbal, what outcomes do they have? Well, we're going to be looking at tons of data sets, but this is just a sense of what we're talking about. So then online, there's a bunch of data sets available. And this is where sort of depending on what you're interested in, you would say, okay, well, I want to look up this particular data set. So one fun thing is on the Duke Athletic website, tons of statistics on all the athletic teams. And so I could pull up each of you guys and sort of see how you compare with your teammates and run all these statistical analyses. And I think that's why they do it, is they put it up there so that people can sort of see trends or patterns. But This is the one for youth basketball. You can go to all these different links of individual statistics. There's things like unemployment rate, which you always hear about, but this is on Google. And if you're interested in saying, okay, what's the unemployment rate? Let's see, Brittany's from Ohio. Let's look at the unemployment rate in Ohio. So red line is the U.S. as a whole, and then Ohio is the blue line. Let's see, Tennessee, Brentwood, Tennessee. And then, let's see, California. Ooh, California's got
more people than
Oh, okay. That's good. So,
plays a big.
what do you notice about this column right here? What is it saying? Percentages. So that's a great point, Tim. I mean, that's exactly what you have to do in this class, is be like, wait a minute, California has more people, so they're going to have more unemployed. So if this axis was total number of unemployed, then that would be exactly right, because we would expect California to have more. But the way that they've made this axis is percentage. So what percentage of Californians are unemployed? It takes into account the number of people. Does that make sense? Well, Ohio is winning right now. That's impressive.
Really weird. I know my count, because I'm in Lorain County, and they just released numbers that were not. I think we're at like 6%.
Oh, really? Yeah. So good. This is good. Being critical of the data that we see, like that doesn't seem right. And so maybe if we look at this, we'll find out that this is data from 2006.
It's 2011.
Oh, there you go. So I don't know. So that's a good thing. Let's see. Where are you from?
Florida.
Florida. That's right. Florida's up there. Basically, though, say you're interested in, or say for your senior thesis or a project that you need to do, whatever topic you're interested in, there's probably data available to look that up. So if you're interested in unemployment and how does unemployment vary by state and why does it vary by state, that's where you would go. How many of you guys have heard of the General Social Survey? It's called the GSS. Has that come up in any of your classes? Well, you're going to become familiar with it, because it's what you're going to be basing your research project on, is the General Social Survey. And the General Social Survey is a survey that's been done since 1972 of the U.S. population. And it asks tons of questions about the general U.S. public and collects it over time so you can look at trends. So what's a sociological topic of interest? I'll start with McKay. A characteristic that you'd be interested in. Wealth, okay. I'm going to do income because that'll probably be closer. You're going to go into this line here and it says search. I want stuff on income. And so what it shows you is all the variables related to income that they've collected. So first one is a husband or wife earns more dollars. So that would be, does your spouse earn more money than you do? What's your total family income? Another question down here is, should government reduce income differences so you can get a sense of people's attitudes? Does this person think the government should play a role in reducing income differences? Another question is income alone enough for happiness and satisfaction in life? Does the person agree with that or not? Another question is, have you ever received welfare? So like any type of subjects like wealth or whatever that you'd be interested in, there's a good chance that something related to it was asked on this survey. We're going to be going through this more, but as you come up with your research paper, this is the data that you're going to use. So you're going to be asking questions about people in the U.S., and it's going to be using this data. The other option would be to have you go out and collect data, but that would take a lot of time and a lot of money. And I figured this would be simpler. And since if you're all kind of looking at the same data set, then you can help each other out and say, hey, I found this variable, or I'm using this variable. So this gives you a sense of the General Social Survey, and it gives you a sense of data that's out there about the U.S. population. Looking at a study that was done in California, it's autism study. The interesting thing for me about this study is this is autism rate by school district. And so this gradation sort of shows the lightest is the fewest number of autistic diagnoses up to darkest is the highest. So a lot of times they're thinking, okay, what's the medical causes for autism? But what this study looked at was what are the sociological factors associated with people getting autism? And you think, well, wait, it's a medical thing. It's not a sociological thing. But what they found was that in places with higher education and higher income, the autism levels were spiky.
So that's where they have to go to get a better education. I mean, if I'm a parent of my kid who has autism, I'm pretty sure I'm going to try to put them like me.
But would you be able to change your education level Like, say your education level is you have a bachelor's degree, and then you get married and you have a kid and your kid has autism. Is your education level going to change? And your income. What they did was they went around to all these parents and they asked them, has your kid been diagnosed with autism? And you'd say either yes or no. And then they'd ask, what's your education level? What's your income? What's your race? What's your religion? They just gathered data on them. Any other ideas of why they would find higher autism rates in places where people were more educated in households that had a higher income? Not in better educated schools, but in the parents.
If you're better educated as a parent and have more money, you're more likely to spend time with your kids, as opposed to if you're working 2 or 3 jobs. You're not going to notice it. Some autisms don't get diagnosed until older ages. So maybe they're more likely to diagnose it. Yeah, that's sort of a combination of factors. Like having health insurance would make you more inclined to take your kid in to get tested. Or if you've read an article about autism and then you're seeing signs in your kid, if you have the money or if you have the knowledge, you're more likely to take your kid in. What's interesting is a lot of times if you go in, you could be driving your car and think, my car drives fine. If you take it into the mechanic and say, are there any problems with my car? They're probably going to find things. So just by the sheer fact of taking your kid in increases the likelihood of them getting diagnosed, even if they have a mild form of autism or a borderline case of autism. And so what they're looking at is, okay, yes, there's an increase in autism diagnoses, but does that necessarily mean that there's an increase in autism? And are there sociological factors driving this? And so that's how they triangulated on, well, gosh, the higher educated, wealthier people are bringing more kids in to be tested. And so then we're seeing higher incidence rates. And that's completely a sociological phenomena, not a medical phenomena. So even in things in medical studies, sociology plays an important role in sort of understanding what's driving certain patterns and trends. But you'd only get that by gathering data, because usually you could just say, well, let's just test the kids' levels of all these different things in their system. But someone said, well, no, let's look at the parents too. And not just the medical history of the parents, but let's look at the sociological factors of these parents and see if there's any trends or relationships. Okay, so types of variables. We've looked at what are variables. Now this breaks down types of variables. The good thing is there's only 2 types. And the first is a categorical variable. And it assigns each case to a category or group. So a case is a person, an organization, or a team, or the thing that you're studying. And variables are the characteristics of that person. A categorical variable would be race. If I'm surveying this classroom and I need to put each person in a category or group by race, it's almost like if you have buckets. And so each bucket represents a different category. So all the black respondents will be put in bucket 1, white respondents will be put in bucket 2, Hispanic respondents will be put in bucket 3. So it's what bucket do you fit in is what a categorical variable is. The idea is you can only fit into one bucket. So you might say, well, gosh, there's a multiracial person in our study. Do we put them in both buckets? Well, you realize, oh no, we need a 4th bucket called multiracial. Each person can only fit into one category. That's a categorical variable. Another would be religion. So again, you have these buckets. Do you go in the Catholic bucket, the Protestant bucket, the Jewish bucket? Or you might say, I have no religion, so we'd have to create another bucket called no religion. For each person, what category do they fit in for the one of interest? These variables are also called qualitative variables because they're more subjective or based on the definition. So someone had to define what black is, and then based on that definition, you put people into buckets. Or they have to sort of say, well, when we're talking about Protestants, this is what the category Protestant includes. Actually, with race and ethnicity, if you go down to Brazil, race categories are very different than they are in the US. So that's why they're more qualitative. The other type of variable would be quantitative. They contain numerical values for each case. Example would be age. So it's anything that has sort of a numerical value is going to be a quantitative variable. So age, income. The benefit of quantitative variables is that you can perform mathematical operations on them, multiply them or square them or do different things to them, and it'll change all the data in the data set. Okay, here's the question. What type of variable would education level be?
Did you say qualitative?
Mm-hmm.
So categorical. What would be the buckets?
Different grades.
Okay, so first grade, second grade. Okay. So that would be an argument for being a categorical. Can anyone give an argument for how it could be seen as a quantitative? Brittany.
Especially with high school, you can do a quantitative what grade number you're in, or like how many years of education. So if you're in a specific field, like how long.
Okay, yeah. And both are right. So categorical would be highest degree earned, like what Tim said. So did you get a high school diploma? Did you get a bachelor's degree? Did you get a graduate degree? Or it could be quantitative, where how many years have you been in school? And so you compare, I've been in school for 12 years, 14 years, 18 years. So it could be a quantitative. So there's only two options, categorical or quantitative, but it's important to know which one you're dealing with. And it's not always immediately obvious. If we look at this, can you pick out one categorical variable? Okay, very good. You're either in the male bucket or the female bucket. Let's see, Rachel, can you pick a quantitative? Perfect. Basically, you'll have a score, and it's a numerical score. So the green ones here are the categorical variables. So even like year, are you a fourth year, second year, even though it's a number, it's still a category because it's sort of like a bucket that you're going to be placed in. Whereas the quantitative are these. What's a way that we could turn piercings into a categorical variable?
You just make it a yes or no question.
Yes, exactly. So again, you can toggle between these or whatever, but it's important to know what you're dealing with. Am I working with a categorical variable or am I working with a quantitative one? Birth order, that's an interesting one. If you're interested in firstborn characteristics versus secondborn or thirdborn, that would be categorical. So like, again, with piercings, if you're interested, well, what's the difference between people who have piercings or don't have piercings? Or what's the difference as you increase the number of piercings a person has? That would determine how you look at the variables. Oh, yeah.
Could you change like anything quantitative to like categorical? So if you said like, instead of for height, or I mean for weight, you could go like anything above 150?
Yep, yeah. And that's a lot of times what people would do, like poverty level. Like you look at income, might be a quantitative variable, but you're like, okay, I'm interested in the difference between people below the poverty line and people above the poverty line. So you've taken a quantitative variable and you've created two categories. And that's often done. High school degree, for Duke students, this really isn't an interesting variable because you have to have a high school degree to get into Duke. And here's missing values. So this doesn't mean the person has zero piercings. It's just we don't know. We're going to stop right there, but that gives you sort of an overview of data, and tomorrow we'll be looking at structure of data. I will post the assignment up on Sakai, but basically you can see on the schedule it's reading sections 1.1 and 1.2.